everything can be found in Google Classroom, and I mean everything. I started doing this, like recording lessons and posting everything online, like well before COVID. Let's see, it must have been about 2018. I went back to teaching in high schools, and I was like, we have the technology to do this. And at the time, again, just like your school, I was in a school where like 70% of the kids did sport. And so I'd have classes where, like, you know, last period of the day, half my class is gone for soccer or cross country or whatever it was. So it's a really valuable thing. So please use those video notes. Okay, we are today talking about measuring segments, and this is weird stuff because it's completely obvious most of the time. So we're going to put it all out there from the very beginning. So the distance between 2 points, like here, A and B, can be written as the length of segment AB. So I'm using my symbol here for segment, which is just a straight bar. And that straight bar we read as segment, okay? So maybe I want to just draw an arrow and say that's the word segment, just so we remember. So the distance between 2 points, you know, like we might want to measure with a ruler or whatever. So we can measure it with a ruler, but it is also, we refer to it as the length of the segment. So the length of segment AB. Or this is the long way to do it. I can also just write it just AB with nothing over top. And what that means is it is a length. So if you see just AB, that says it means the length of AB. All right, and so we can say that in this case, this is saying the length of AB. How long? Yeah, the length of AB is 4. How did you get 4? Okay, -1 plus 4 equals 3. So we can also do B minus A or A minus B, but we think about it as absolute value, actually, because we're talking about a distance, and that, of course, should always be a positive answer. So whether or not you did point A minus B, so if we did -1 minus 3, -1 minus 3 would be -4, and then inside absolute values, it comes out as 4, which is what we expect it to be, okay? So good to subtract things, and that'll give us our distances, right? That's very obvious. We put it inside absolute values, and we'll get a positive, which is what we want when we talk about the length of something or the distance of something. It should be positive. All right, so if, in this particular picture, AB is equal to CD. And again, this is all notation here, so there's no segment bar above it, so we're talking about the length of a segment AB is equal to the length of segment CD. And so it's really, we have to, this whole language that we're learning to create here. If the length of segment AB is equal to the length of segment CD, are they? This one is 4, and CD is also 4. Okay, good. Then that is what is known as the word congruent. When two segments are equal in length, they are called congruent, okay? And congruence is written like this. We would say segment AB is congruent to segment CD. So this is the congruence symbol right here. It's an equal sign with a little tilde over top of it, and that is the word congruent. And segments can be congruent. They appear to be identical, even though they're in a different place in space, okay? but the segments are congruent if they have the same length. Okay, great. Now, we have this postulate, the segment addition postulate we're going to get used to here. If A, B, and C are collinear, what does collinear mean? On the same line, very important. And B is somewhere between A and C, then, if I have this length, I don't know what that is, but we're going to call it AB. And again, with my notation, that's saying whatever that length is, that length between A and B, plus this little piece here. What can I call that little piece there? BC. Hey, look at that, BC. All right, if I have this little length right here, AB, plus this little length, BC, what does that equal? AB, BC, sort of. Could I just go the whole thing? Can it just equal the whole thing? Does that make sense to you? The whole length of AC. All right, also known as part plus part equals whole. Hey, look at that. We're back to kindergarten. Okay. Little piece plus little piece has to equal the big thing. Is that correct? Does that make sense? Okay, good. So we are using, and this is called the segment addition postulate. Part plus part equals whole. All right? So here again, we have this little diagram we're going to use for questions 1 and 2 here. And of course, if I'm looking at this diagram, what would my segment addition postulate be for this diagram? PQ plus QR is equal to PR. Very good. Little piece plus little piece equals the whole thing. Okay? Oh, you can't really see that. There you go. Sorry about that. So little piece plus little piece equals the whole thing. All right. Let's look here at the information on number 1. PQ has a length of 9. I'm going to go ahead and just write in a 9 on my picture. Today you're going to find that drawing a picture is going to make a world of difference. Okay? And QR right here, QR is 28. Yeah, what's PR? Yeah, how'd you get 37? Yeah. The whole thing is simply 9 plus 28. 9 plus 28 equals 37. Really, that one was easy. Okay. What about, I'm gonna draw the picture over here. I'm gonna redraw the picture just so everybody's seeing the same thing. QR. Okay. So on number 2, QR is 17. And PR is 21. Yeah, how'd you get 4? Yeah, so we have the whole thing, and if I subtract 17, that's going to give me this leftover bit right here. Does that make sense to you? Easy with numbers, right? Super easy with numbers. So we get 4. So PQ is equal to 4. And again, having a little picture makes it super easy. If you draw a picture and just write 4, I understand what you did. Does that make sense? Okay. So having a picture can be super, super nice. Now, of course, they're not always that easy. They are going to get much more challenging. And so we want to just make sure we're understanding this super well. E.g., so we have a nice little picture that's been drawn for us. EG, though, it says EG, that's the whole thing, is 71. So I'm going to mark that on my picture, too. And we want to find the value of x. We also know, what do you think this is telling us when we have 8x minus 17? What is that telling us? It's the length of EF. Yeah, it is the length of EF. And they're just using it in algebra form. Okay? And then 5x minus 3 is representing the length of FG, okay? Now, if we're thinking about segment addition postulate, then I should be able to say little piece plus little piece equals the big piece, okay? So we're going to write that down. We're going to say, hey, this little piece, 8x minus 17, plus another piece, 5x minus 3, equals the whole thing. What's the whole thing? 71. All right? Little piece plus little piece equals the whole thing. All right? This is part one. Now we just use our algebra skills to solve. Okay? So this is my equation. And what do we need to do? Combine like terms. Very good. So 8x's plus 5x's is 13x's minus 20. Very good. Negative 17 and negative 3 equals 71. Add the 20. So you get 13x equals 91. And then divide by 13, divide by 13. So we get x equals 7. Beautiful. And so they asked us to find the value of x. Did we find the value of x? Yeah, x is equal to 7. The biggest problem with geometry is that you are awesome at solving for x, and sometimes our job is to solve for x. And if it says solve for x, you're done, because that's what we did. But more often than not, we have to go a step further, because here on number 4, they're telling us TV. What is TV? The full thing, the whole. The whole thing is 14x minus 8. And what is our job here? Find TU. And again, we have to think about notation. TU has nothing on top of it. So it's saying we need to find the length of TU. We want to actually know the number of how long it is. Like how many inches or centimeters is it? That's what we're trying to figure out. So we have one more step to do other than solve for x. So I'm going to show you that. Let's see. 9x plus 2 is just TU, and 5 is UV. How should we set this up? What's our setup here?
9x plus 2 plus 5 equals 14x plus 8.
Yes. Piece, here's our little piece, 9x plus 2, plus the other piece equals the whole 14x minus 8. That is a 14. All right, piece plus piece equals whole. All right, little piece plus little piece equals the whole thing. And now, again, I'm going to clean this up. I've got 9x plus 7 equals 14x minus 8. What do you want to do? Minus the 14x? Sure, I can subtract 14x. Can I do a 2 steps in one here? Can I also subtract 7 from both sides? And again, there's multiple ways to solve, so you could have done things a little different. Let's see, 9 minus 14 is negative 5x's, and negative 8 and a negative 7 is a negative 15. And then I need to divide by negative 5, so x equals 3. Beautiful. Am I done? No, they didn't want us to just solve for x. That was step 1. So I have to find TU. TU, the length of TU is 9x plus 2. What do I need to do with my value of 3? Plug it back in. Plug it in, plug it in. So here, it's telling us, hey, we know that TU has a length of 9x plus 2. I got to plug in the value we just found. So 9 times the 3 plus the 2. And you can use your calculator. This is a great thing for a calculator, but it's not hard. 27 plus 2 is 29. All right? That is what we were looking for. So plugging something back in, something we have to do a lot in this class. Okay. Let's see. Let's do number 5. JL is, okay, JL is the whole thing, 5x plus 2. So I have some little pieces and I have a whole. What's my setup going to be? Good. 3x minus 1, so that's this piece right here, plus the jk, 27, equals the whole 5x plus 2. Piece plus piece equals whole. Does it matter? Could you have done like 27 plus 3x minus 1 equals 5x plus 2? Could you have done it that way too? Absolutely. Okay. You're going to get the same thing. Let's see. So I have a 3x plus 26 equals 5x plus 2. And I'm going to go ahead and subtract, because I like to put my letters to the left. I'm going to subtract that 5x to the left-hand side, and I'm also going to subtract 26 to the right-hand side. So I have a negative 2x is equal to negative 24. Divide by negative 2, so we get x equals 12. Are we done? No. We want to find JL here. So once again, we've got one more step. JL is what? 5x plus 2. Good. And then what? Plug the 12 in place of the x. So we have 5 times 12 plus 2, so JL equals 62. So 5 times 12, what was your question? No? Good? Okay. 60 plus 2 is 62. All right. It's a lot of algebra. That's why we started solving equations before. Okay. Let's do one more, and then we're done. Let's turn the page to number 7. Today in your Delta Math, the pictures are not readily available, okay? So you must learn to draw your own. So no picture, no problem. Draw your own. It says, reading carefully, point B is on line segment AC. So I am going to draw a line segment. A line segment starts with a letter and ends with a letter. So A and C are the end points of our line segment. And B is somewhere on there. Does it matter where it is? No, but it's somewhere on there. So I'm just going to put it right there. There we go. I'm going to draw a point and call it B. Now it says AC. AC is the whole thing. So the whole AC is 2x plus 7. BC, that's just this little piece, is called x. And AB is 5x minus 9. Do you think you can draw your own picture? Yeah, it's pretty easy, right? Okay. So the important part here is that we have a line segment AC, and we want to make sure that our A and C are the end points of that segment. That's the real part that matters, okay? All right, so we want to set it up. What's our setup for this question? Good. 5x minus 9 plus x equals 2x plus 7. Let's see. 5x's plus another x is 6x minus 9 equals 2x plus 7. And then what am I going to do? Minus 2x minus 2x. And I'm also going to add 9 to the right and cross it out. All right. So that's going to give me 4x is equal to 16, which means divide by 4, x equals 4. Are we done? No. This one wants the numerical length of AB. So we want to find the length of AB. Yeah, so we have AB is 5x minus 9, so we're going to do 5 times 4. minus 9. Can I do that right like that? Is that totally fine? Yeah. Could you also just like maybe do it in your head and get 11? Yeah, that would also be fine. So read carefully, make sure you're answering the question that's asked is really the hard part of geometry, okay? Do you guys have any questions for me? What's the segment addition postulate? In the most simplified form. Part plus part equals whole. That is the segment addition postulate, okay? Part plus part equals the whole thing. And that's all we have to think about, okay? All right, you guys have a delta minute. 20 minutes exactly.